Good morning. I am Jyoti Kumar. Today I am going to discuss about the topic semaphore. It is a technique to manage the concurrent process using a non-negative integer variable that is shared between threads. These variables is used to solve the critical session problem to achieve the process synchronization in the multi-programming environment. Here we have two atomic values. One is weight, other one is signal. Here we have weight and signals. Here we have weight of S while S is less than or equal to 0 colon S minus minus. When I am representing while S is less than or equal to 0 colon, meaning that if it is true, the process will not enter into the critical section. If this is false, then the process is entered into the critical section. And S minus minus, decrementing the value of S. Here, while S is less than or equal to 0, since S is less than or equal to 0, the process will not enter into the critical section. If the value of S is set to be 1, the process enters into the critical section. Meaning that if I represent if S is less than or equal to 0, no other process in the critical section, so that the process will enter into the critical section. And then once the process enters into the critical section, I am representing the value of S should be decrementing. I am decrementing the value of S. If I am decrementing the value of S, then value of S is less than or equal to 0. Once again, it changes 1 to 0. Now, meaning here is, since the value of S is less than or equal to 0, so no other process will enter into the critical section because already one process there in the critical section, so that it will not allow the other process to enter inside the critical section. Coming to signal operation, signal of S. If the process is completed and the resources is free, then we can use the particular resources using some other process, so that I can represent the value of S is incrementing here in this. Here we have two type of semaphore. One is counting semaphore, other one is binary semaphore. In binary semaphore, we have two values, zeros and ones. So if I am representing the value of as 1, then the process will enter into the critical section. If the S is less than or equal to 0, the process will not enter into the critical section. This is the process in binary semaphore. It is used to implement the solution of critical section problem with multiple processes. Coming to the counting semaphore, simply we can say it is used to control access to the resources that have multiple instances. If I have one resource and have one more instance of the particular resources, so I can term the value of resource is said to be true. So while S is less than or equal to 2 in that case. So since while S is less than or equal to 2, I can possibly enter the process inside the critical section. And again, if the 2 is set to be 1, I mean S minus minus, again we can enter one more process to enter into the critical section. Then the value of S is less than or equal to 0. In that case, it will not enter the other process to enter into the critical section because the resources are not free. Since we have two resources, including that instance, I can allow two processes to enter into the critical section for each resources respectively. So we can call the counting semaphore is used to control access to the resources that have multiple instances. Thank you.